Okay, geometry students, today we're going to look at the second of our transformations in the Cartesian coordinate plane, and that would be the reflections. Please copy down the title, Reflections in the Cartesian coordinate plane. Let's have a look at our objectives for the day. Our stated objective is to learn to apply reflections to objects in the Cartesian coordinate plane. Now what you're going to see today is that it's not nearly as easy as the translations were. Okay, there's a little bit of a procedure that we're going to have to adopt and adapt to. And unfortunately, this is kind of a conditional procedure, meaning in some cases we will do one thing, and in some cases we will do a different thing, depending on what's happening in the graph before the reflection occurs. The student will demonstrate the ability to reflect provided objects by, I've got a grammar issue in that sentence, reflect provided objects across indicated lines within the Cartesian coordinate plane. And your essential question, can I reflect an object in a graph? Okay, so let's get started. Reflections. Now, if the mirror that is in the graph that we are reflecting across is parallel to an axis, the image will be the same distance behind the mirror as the pre-image was out in front of it. This is very similar to reflections that you have done just on blank pieces of paper where there has not been a graph really involved. Obviously, the reflection should be the same distance out behind the mirror as the real object or the pre-image is out in front of it. So this is not that bad. And in fact, being in a graph actually makes this a little bit easier as far as reflections are concerned. Some of us are not the best artists that were ever born. Having it in a graph actually helps us keep the information fairly positioned correctly. Okay, so let's say we're looking at a graph here, and we have a triangle ABC, and we have coordinates of triangle ABC. A is at -6, 2, B is at -4, 5, and C is at -1, 3. Our instructions for this problem are to reflect triangle ABC through the y-axis. As I said, this is really very simple because if the y-axis is the mirror, then all of these points, point A and point B and point C, they are a certain distance away from the mirror. So when they look into the mirror, they are going to see themselves the same distance out behind the mirror. Okay, so it's not a big issue, okay, and I'd say move it 1 point at a time to eliminate any possibility of silly mistakes. Point A is going to look into the mirror. Point A is going to see that he is 6 units away from the mirror, so his reflection is also going to be 6 units out the back side of the mirror, and that's where point A prime is going to exist at. Okay, 1 point at a time. Point B looks into the mirror. He is going to see himself the same distance out behind the mirror as he was in front of it. So it's 4 units to the mirror for point B. So point B prime is going to be 4 units out the back side of the mirror. And point C. Point C is quite close to the mirror. It's only 1 unit to the mirror for him, so his reflection will be 1 unit behind the plane of reflection. So there we will have the position of C prime. You connect the dots and you have your image. Okay, so what are the coordinates of the new triangle? This is really the only thing that might be different from doing a reflection out in an open sheet of paper, would be having to identify where the coordinates are. So we need to know the coordinates of A prime and B prime and C prime. Okay, and obviously in this case, since the y-axis was the mirror, it's the x values that have changed. The y values are the ordinates. They are the same amount above the x-axis as they were before the reflections. So all we really have to do is worry about the x values. Okay, so our point A prime is 6 units now on the positive side of the x-axis and still 2 units above the x-axis. B prime is 4 units above, or now 4 units out on the positive side of the x-axis, and still 5 units above, 5 units up on the y-axis. C prime is now aligning with 1 on the positive x-axis and is still up at 3 on the y-axis. So there's your coordinates of your translation. Okay, now, as was the case just on a blank sheet of paper when you're doing a reflection, as we saw yesterday with the smiley face, doing the reflection on a blank sheet of paper is easy if the plane of reflection is perfectly vertical or is perfectly horizontal. Very little chance of us making any mistakes. But what happens if the plane of reflection or the mirror is slanted? And one of the favorite choices that test writers love to ask you about is the line y equals x. Okay, so let's take a look. What happens if the mirror is y equals x? Okay, in this case, the abscissa, which is the x value, and the ordinate, which is the y value, are going to switch places. Okay, so let's take a peek at a graph here. And let's look at triangle ABC once more. Okay, this time we're going to say we're going to reflect through the line y equals x. Now, if you're not familiar with y equals x, we'll get to him here in a second. Now, once again, on the last example, it wasn't that important to know the coordinates up front. This time it's going to be. If we're going to switch the x value and the y value, we better know what they are. Okay, so once again, A is at -6, +2, B is at -4, +5, and C is at -1, +3. That's going to be important. Okay, reflecting through the y-axis like we did a moment ago, or if we had reflected through the x-axis, it wasn't really that important to know the coordinates in advance. We could have found them out later on after the image had been assembled. This time we're not going to be able to assemble the image without knowing the coordinates first. Okay, now if you're not familiar with the line y equals x, here it is. This guy is referred to as the parent linear function. If you've not heard that term before, parent function, you absolutely will in Algebra 2. You're going to spend basically an entire semester working with parent functions. This is the parent function, which means the most basic format that a particular type of graph has to offer, and this is the most basic line that we have. He passes through the origin with a slope of +1. So his equation is actually y equals 1/1x plus 0. Okay, he doesn't have any changes made to his equation whatsoever, simply y equals x. Okay, they'd like to pick on this guy for us to reflect through. Let's take a look at what the coordinates of our new triangle, our image, are going to be. So obviously we're going to have A prime, B prime, and C prime after the reflection. And the rule says the abscissa and the ordinate are going to switch places. Okay, so that being the case, let's have a look. If A is currently at -6, 2, and we're going to switch those in order to end up with A prime, then A prime is going to exist at 2, -6. And there's where A prime is going to exist at in the graph. B exists at -4, 5, and since we're reflecting through the line y equals x, we're going to switch the x and the y value, and we get 5 and -4. And there's point B prime. C is currently at -1, 3, reflecting through y equals x. We switch the abscissa and the ordinate, and he exists at 3, -1. So plot our point, label it, connect the dots, and we have our image. Okay, so that's not too bad. You just have to remember that there is a procedure if the line is y equals x. However, that's not the only line that they reflect through. From time to time, they will ask us to reverse the slope of the parent function and reflect through him. And here's where things go a little sideways on us. If your points or your object exist in odd quadrants, we have a particular procedure. So the odd numbered quadrants are 1 and 3, and we'll get to that more here in just a second. In even quadrants, which are quadrants 2 and 4, we're going to have a different set of procedures. So first things first, let's make sure we know where the quadrants are and how they are named and numbered. You should know this already. If you do not, it is definitely time for you to learn it. Okay. Obviously, the Cartesian coordinate plane is divided into space, two-dimensional space. Okay, and all two-dimensional space is divided around the axes, which of course intersect at the origin. Now the space that is around these axes, you can see it divides all two-dimensional space into 4 equal areas that extend outward as the axes extend outward. The quadrant that is up and to the right of the origin is the one that we call quadrant 1. Quadrant 1 is where the axes are both positive, positive x and positive y. That is quadrant 1. From there, we rotate counterclockwise, and you have quadrant 2, continuing to rotate counterclockwise around the origin. We've got quadrant 3, and then finally quadrant 4. That is the numbering system for the quadrants. You absolutely need to know this. And there are your odd numbered quadrants. Okay, quadrant 1 up and to the right, and then vertically from that, quadrant 3 down and to the left. Those are your odd numbers. And then, of course, quadrant 2 and quadrant 4 are your even numbers. Okay, and of course they are vertical from each other as well. Now, depending on whether we're in an odd quadrant or an even quadrant, we have a different set of rules to follow if our line of reflection is y equals negative x. In the odd quadrants, once again, we're going to exchange the positions of the abscissa and the ordinate. Okay, that is just like we did with y equals x. However, this time we're also going to find the need to change the signs of those values as well. In the even numbered quadrants, 2 and 4, let me finish that off. So a comma b, where a is your x value and b is your y value, becomes negative b comma negative a. Okay. Now keep in mind, that does not mean that a and b are always positive in the beginning and then they always become negative as a result of the reflection. Okay, because a might be a negative value to begin with, and then when you change its sign, it might become positive. B might be a negative value to begin with, and then when you change its sign, it becomes positive. The point is, a and b are going to switch places, and a and b are both going to change their signs if we are in the odd numbered quadrants reflecting across y equals negative x. In the even numbered quadrants, once again, we're going to exchange the positions of the abscissa and the ordinate, but we're going to leave the signs as they were. Okay, so if you start off with a point like negative a comma b, and you reflect through the line y equals negative x, then that coordinate will become negative b positive a. Okay, so let's take a look at an example of this one. Okay, here we have a triangle ABC, and our instructions are to reflect through the line y equals negative x. Well, y equals negative x still passes through the origin because it does not have a listed y-intercept value. However, the slope value this time is negative, so instead of climbing 1 and running 1, this time it is falling 1 and running 1. So this one is not a parent function because it has definitely been changed. Okay, so going downward rather than upward. However, let's take a look at the reflection. Okay, just a little notation here. That's from the previous screen in odd quadrants. We're going to switch the values and change the signs. In the even quadrants, we're going to switch the values but leave the signs where they were before the switch took place. Okay, so we're clearly going to need to know the coordinates. Point A lives at negative 1 comma 4. Point B lives at 4 comma 5. And C lives at 6 comma negative 2. Okay, so let's see if we can discover where the new coordinates are going to end up. Okay, let's start off with A. A is in quadrant 2. That is an even numbered quadrant. So the rule is to switch the abscissa and the ordinate, but leave the signs where they were. So if A is at -1, 4, we're going to switch those values. So the 4 will come first and the 1 will come later, but we're going to leave the signs as they are. The first value will be negative, the second value will be positive. So that means A is going to be at -4, and B, the x value will be at -4, and the y value will be at +1. So there is the coordinate for A prime. Point B is at 4, 5. Okay, that is in the first quadrant, which is an odd numbered quadrant. So we're going to switch the position of the abscissa and the ordinate, and we're going to switch their signs also. So 4, 5 becomes 5, 4, and positive, positive becomes negative, negative. Sorry, I have a typo right there in my notes. Let me fix that. Should have been a -5. Okay, and we can plot it right there. And I'm going to have the same typo on every single one of my sheets, so I'm changing it. Okay, so there is point B prime at -5, -4. Okay, looking at point C lives at 6, -2. 6, -2 is in quadrant 4. That is an even numbered quadrant, so the rule says we're going to switch the x and y values, but we're going to leave the signs exactly as they were before the switch occurred. So if we are at +6, -2, we're going to switch the 6 and the 2, but we're going to leave the first value positive, change the second value to negative. So if that's the case, we are going to have an x value of +2 and a y value of -6. Plotting that point, we are at that location that just showed up in the graph. And of course that is C prime. Okay. From there we can connect the points and we have our image. Okay, so we got a little bit of stuff we're going to have to get memorized as far as procedure is concerned. Obviously, it's not all as easy as translations were. Okay, but this is manageable. We got 2 different sets of rules depending on which quadrant we are in, reflecting over the lines y equals x and y equals -x. You're absolutely going to have that memorized. If they do ask questions about reflections over these lines, they are not going to tell you what you need to know in order to do it. So you're going to have to come with this information pre-programmed in your brain if you're going to get it right. Okay. So take a quick moment, jot down a summary that kind of wraps up this lesson. Notate any questions that you need to come in and ask questions about, and always keep your essential question in mind. Can I reflect an object in a graph? I appreciate you finding time to get your notes taken care of. I'll see you in class.